Started from the bottom, now we're here. Started from the bottom, now the whole team here. Yeah, started from the bottom, now we're here.
Okay, so this is Chapter 3, 2D Motion. So these are some of the things that you need to know. Basic equations are VF equals VI plus AT. Delta X equals VIT plus 1/2 AT squared. And VF squared equals VI squared plus 2A delta X. Now, if you have an angle vector like this, so this is a speed, you can split it up into two parts. So you have Vx and then Vy. If you have the values for these two, you can use V squared equals Vx squared plus Vy squared to find the value for this by square rooting both sides. And then if you want to find the angle here, you can use tangent inverse of Vy over Vx equals theta. Okay, so these are some real life examples. You could have a ball rolling off the edge of a table. So you could find like delta x or the final speed of it. Or you could have someone throwing a baseball at an angle. Just break this up. You could find delta x. You could find the maximum height. You could find the time it takes. Yeah. Our problem is, assume that Jake is 2 meters tall and he throws a ball 110 meters in 4 seconds to clear a 1.5 meter fence. Find A, the velocity at the point of release, and B, the angle of release. Alright, so this vector represents the velocity at which Jake throws the ball initially. So we'll break it up into Vix and Viy. And so we have to do our problems in two parts, the x part. So we have Vi, Vf, A, T, and delta x. These are unknowns for now. Acceleration is 0, time is 4 seconds, and delta x 110 meters. For y, we have Vi, Vf, A, T, delta y. Delta y is negative 2 meters, time is 4 seconds, and acceleration is negative 9.8 meters. Positive direction is up here and to the right here.
Yeah.
So in the x direction, we'll use the equation delta x equals Vi x t plus 1/2 a t squared. A is 0, so that just becomes 0. And so we have 110 meters equals Vix times 4 seconds. Divide over the 4 seconds, and we get Vix equals 27.5 meters per second. Okay, so now for the y direction, we have delta y equals Viy t plus 1/2 a t squared. So this becomes negative 2 meters equals Viy times 4 plus 1/2 negative 9.8 and then 4 squared. So this becomes negative 2 meters equals 4 Viy minus 78.4. So then this becomes 76.4 equals 4 VIY. So then you have VIY equals 19.1 meters per second. So we'll use the equation VI squared equals VIF squared plus VIY squared. So you plug in the two numbers and then square root both sides, and you end up getting VI equals 33.5 meters per second. So now for part B, we're trying to find V initial, or the angle right here. And so we have these two values as 19.1 and 27.5. So we have tangent theta equals 19.1 over 27.5. That turns into theta equals tangent inverse of 19.1 over 27.5. So theta equals 34.78 degrees. That's how you do that problem. Time, bunch of different stuff.